Alright, so we're finally into our actual operations with fractions and mixed numbers. This first section, we're going to look at the two of our easiest operations, which is going to be multiplying and dividing fractions. This comes from sections 2.5 for multiplication, 2.7 for division, and 9.3 for signed fractions. So the first thing that we're going to do is we're going to look at this visually, and we're going to use area in order to show how this works. So what we want to do is we are going to start by creating a rectangle, and we want to divide and shade the fraction indicated by the first number along one side of the rectangle, or our length. We're also going to divide and shade the fraction indicated by the second number along the other side of the rectangle, or our width. The numerator is going to equal the number of segments shaded by both colors, and the denominator is equal to the total number of segments created. So let's go ahead and look at an example of this. We create a rectangle, and for my first fraction I have 3/4. So I want to remember that the bottom number tells you how many segments in the whole rectangle. This is going to be 4. 3/4, I'm going to shade 3 of them. So on this side we have 3/4. Now along the other side I want to shade 3/5, so I want to divide my rectangle into 5 segments because of my denominator. And again I want to shade 3 of them. So now I want to know what is shaded by both colors. So shaded by both colors, we have this one is shaded The ones that I am coloring over in black are shaded by both the blue and the green. And so when we go ahead and figure out our fraction, how many are shaded by both? That is equal to 9. Over how many total segments do I have I created in this rectangle? There is a total of 20. So what we get is 3/4 times 3/5 is equal to 9/20. So now looking at this problem, can you tell me how we get from 3/4 and 3/5 to 9/20? Our basic rule when we talk about multiplying is we multiply straight across. 3 times 3 gives me the 9, and 4 times 5 gives me the 20. And that's our basic rule for multiplying fractions. So let's go ahead and talk about our procedure now without doing this visually. So our procedure to multiply fractions, we want to multiply straight across, meaning that we want to multiply the numerators together, and we want to multiply the denominators together. From there, we want to reduce the fraction by dividing by the greatest common factor, like we did in the previous section. If we have signed numbers, we do want to use our rules for Module B to determine the sign of the final answer. Remember that if there is an odd number of negatives, our answer is negative. If there is an even number of negatives, our answer is positive. Now, there is one thing that we can do is you can multiply and then reduce, but an alternative method, and one that I prefer to use, is to cancel common factors and then multiply. This makes sure that your numbers are smaller, they're easier to work with, and it's easier to see how things simplify. So what we do is we cancel common factors that appear in a numerator and a denominator. Note they can be in the same fraction or in different fractions. The main thing is it has to be a top and a bottom. Once we've canceled our common factors, then we can multiply the numbers that remain straight across. Okay, so a couple things to note when we talk about multiplication. The word of by itself means multiplication when working with fractions. We will see it again when we talk about percent. Now, what if one of our numbers is a whole number? If either number is a whole number, we can start by rewriting it as a fraction with a denominator of 1. Put it over 1, and now it does have a numerator and a denominator. All right, so let's go ahead and look at some examples. Let's start with example A. We can go ahead and multiply straight across. We get 5 times 3 is 15, and 8 times 4 is 32. 15 and 32 have no common factors, so this is in simplified form, and we're done. Example B, same thing. I can multiply straight across. If we multiply straight across, we get 4 times 2 is 8. 7 times 5 is 35. 8 and 35 have no common factors, and so we are done. All right, example C. If we multiply straight across, I'm going to just work with the numbers first. We get 3 over 8. I do have a negative in my problem, and so I want to keep it. 3 and 8 have no common factors, and so we are done at this stage. Okay, now these are the base case examples, so now let's get into something a little bit more challenging. Let's look at example D. Example D, let's go ahead and multiply straight across to start off with. First off, remember that the word of means times. So if we multiply straight across, we get this is equal to 3 times 5 is 15. 10 times 6 is 60. Now, 15 and 60 do have common factors. In fact, they are both divisible by 15. And so we want to divide top and bottom by 15. And if we do this, we get 1 over 4. Now, these were not horrible numbers to work with, and so multiplying and then canceling was pretty easy. But let's go ahead and talk about another way that we can do this. The other way that we can do this is, again, we can cancel common factors with tops and bottoms. So for instance, 3 and 6 are both divisible by 3. If we divide 3 by 3, we get 1. If we divide 6 by 3, we get 2. Similarly, 5 and 10 are both divisible by 5. So if we divide 5 by 5, we get 1. If we divide 10 by 5, we get 2. And now working with the numbers that we have now, if we multiply straight across, we get 1 times 1 is 1 over 2 times 2 is 4. And so notice that we're going to get the same answer either way. Now, as I said, me personally, I like canceling common factors first. That way my numbers stay smaller, more manageable, and I'm less likely to have to pull out multiplying two-digit numbers by hand. It just makes it a little bit easier. These are, if you simplify first, you're less likely to need that. You're more likely to be able to just do this mentally. All right, let's go ahead and try a couple more using this technique. If we look at example E, do we have any numbers with common factors? The answer is yes. First one I see is 15 and 5 are both divisible by 5. 15 divided by 5 is 3. And 5 divided by 5 is 1. I can actually go even further. 6 and 28 are both divisible by 2. 6 divided by 2 is 3. And 28 divided by 2 is 14. And so now if we go ahead and multiply straight across, we get 3 times 3 is 9. And 14 times 1 is 14. Okay, that takes care of that one. Let's try some more. Let's look at example F. Same thing again, I want to cancel common factors. First one I see is 7 and 7 are both divisible by 7, so we get 1 and 1. What about 12 and 24? Well, you can do 2, 3, 4, 6, but our greatest common factor is actually 12. So if we divide by 12, we get 12 divided by 12 is 1, and 24 divided by 12 is 2. If we multiply straight across now, we get 1 times 1 is 1 over 1 times 2 is 2. All right, example G. Now, one thing we do want to make sure that we keep in mind when we work on this is you might want to get a highlighter so that you can highlight negatives. That way they don't get lost in your cancellations. I'm not going to work with them right now. I'm going to start by doing my cancellations. So if we go ahead and do some cancellations here, I know that 9 and 18 are both divisible by 9. So we get 9 divided by 9 is 1. 18 divided by 9 is 2. Can I cancel anything else? Can I cancel 2 and 20? The answer is no, because they are both in denominators. Remember that it always has to be a top and a bottom. So nothing else cancels here. We can go ahead and multiply straight across. We get 11 times 1 is 11. 2 times 20 is 40. And then now what about the sign of my answer? I can cancel my negatives and my result is positive. All right, let's look at some numbers. Let's look at some problems that involve whole numbers. example H, we have 3/4 of 36. So the first thing that I want to do is I'm going to bring down my 3/4. I'm going to rewrite of as my multiplication sign. And my whole number, I want to write it as a fraction. So I'm going to write it as 36 over 1. From here, we can cancel out common factors. 4 and 36 are both divisible by 4. We get 1 and 9. I cannot cancel anything else, so we go ahead and multiply straight across. 3 times 9 is 27 over 1 times 1 is 1. And please note that this would not be considered a simplified answer. If you can write it as a whole number, you should. So 27 divided by 1 is 27. All right, let's try one more. Let's look at example I. The first thing that I want to do is write 10 as 10 over 1. We'll bring down our times 2/5. All right, if we go ahead and cancel common factors, 10 and 5 are both divisible by 5. We get 2 and 1. Nothing else cancels, so we're going to multiply straight across. We get 2 times 2 is 4 over 1. We do have 1 negative sign, so we keep it. And again, if I can write this as a whole number, or as an integer in this case, we should. We get negative 4 over 1 is equal to negative 4. All right, so now let's go ahead and step up the difficulty. What if we have more than two fractions being multiplied together? This actually doesn't get any more complicated. We still use our same procedures. So just like before, this one I definitely want to cancel before I start doing any multiplications. So if we go ahead and cancel, what can we cancel? Remember, it just has to be a top and a bottom. So for instance, I can cancel 2 and 36. They are both divisible by 2, so I have 1. And 36 divided by 2 is 18. What else can I cancel? Well, I'm going to do it the easy way. I'm going to cancel 18 and 18. And we get 1 and 1. Nothing else cancels here, so we can go ahead and multiply straight across. So on the top, we just have a bunch of 1s being multiplied together, so that's just 1. On the bottom, I have 17 times 1 is 17, times 3. 17 times 3, I believe, is 51. And that is our final answer. Now, if you wanted, you could also cancel 18 and 3. Note that it doesn't matter where you do your cancellations, it just has to be a top and a bottom. So let's come down to example K and see what we can do here. Let's see here, what can we cancel? The first thing I see is my 3's. Both of them are divisible by 3, and if we divide 3 by 3, we get 1. I can also cancel 8 and 4. Both of these numbers are divisible by 4. We get 2 and 1. And I believe that's all the cancellations that we can do here. So now we can go ahead and multiply straight across. 2 times 2 is 4, times 1 is 4, over 1 times 15 is 15 times 1 is 15. So our final answer is 4 over 15. Now as you're doing these, make sure that you check your answer to make sure that it does not simplify further. I did not do it just because I know what the greatest common factors are, and I know that my answer is simplified when I get to the end. But as you work on these, make sure that your answer is simplified. All right, that takes care of multiplication. So the other operation we're going to look at in this section. All right, the other operation that we're going to look at is dividing fractions. Now, division, I always like dividing fractions because it does not actually involve division. If you don't like to divide, don't worry, you're not going to be dividing in this section. So what we're going to do is we are going to use the rule that division is the same as multiplying by the reciprocal. That is its definition. So let's go ahead and talk about what that means. So our procedure for dividing fractions, we're going to rewrite any whole numbers as fractions by putting it over 1. And as I said, we do not divide, we actually multiply. So we're going to change our division sign to a multiplication sign. And we are going to change the second fraction to its reciprocal. Reciprocal, this is the flip of a fraction. So whatever's on top goes to the bottom, whatever's on bottom goes to the top. And once we've done that, we then use our rules for multiplying fractions. Now, a student taught me several semesters ago that he was taught the trick for remembering division is copy, dot, flip. This tells you exactly what to do. You copy the first fraction, dot, flip the second fraction. All right, so let's go ahead and look at some examples of this. If we start with example A, we have 3/10 divided by 4/5. So my first thing that I want to do is I want to multiply by the reciprocal. So I'm going to copy my first fraction. I'm going to change it to a multiplication or a dot. I'm going to flip my second fraction. So it becomes 5 over 4. This is no longer a division problem, this is now a multiplication problem, so we're going to use our rules for multiplying. I want to go ahead and cancel common factors. So 10 and 5 are both divisible by 5. We get 1 and 2. And now if we multiply across, nothing else cancels. If we multiply across, we get 3 over 8. And we're done. All right, let's try a couple other ones. Let's look at example B. We're going to copy the 1/4. We're going to change our division to a dot. We're going to flip the second fraction. So we get 1/4 times 3/2. We don't have anything that cancels, so we can go ahead and multiply straight across, and we get 3 over 8. All right, let's look at example C. Same thing again, we copy dot flip, so we get 3 over 8 dot 8 over 5. We cancel common factors. My 8's cancel, leaving me with 1 and 1. And if we multiply straight across, we get 3 over 5. All right, so those are some basic ones. Let's look at some other types. Now, for D and E, this is just another notation. What they're doing is they're using the fraction bar to mean division. These are also called complex fractions. You don't need to know this, but a complex fraction is a fraction containing fractions. Now I'm going to show you two ways that you can do this problem. The first way is the way that we've been doing it so far. So I'm going to go ahead and rewrite this horizontally. This is the same thing as 2/3 divided by 4/5. Again, we want to copy dot flip. So we're going to 2/3 times 5/4. 2 and 4 are both divisible by 2. We get 1 and 2. And if we go ahead and multiply straight across, we get 5/6. Now another thing that you can do, this is kind of a trick for complex fractions, is outsides over insides. What does that mean? That means I want to multiply my outside numbers, 2 times 5, over my inside numbers, 3 times 4. Now, I would also recommend, if you're going to do outsides over insides, is just write them as products, write them as multiplications, so that you can go ahead and do your cancellations before you multiply. Again, depending on the complexity of the numbers, these can be either easy enough or they can get rather challenging. So if you write it as a product, then you can go ahead and do your cancellations. 2 and 4 are both divisible by 2. We get 1 and 2. And if we multiply straight across, we get 5/6, which is what we got originally. You can also do kind of a combination of the two if you want. All right, so let's go ahead and look at example E. We are getting into larger numbers. And so as I said, me personally, I just like writing it horizontally. So if we do 5/6 divided by 7/12, I can copy dot flip. We get 5/6 dot 12/7. My 6 and my 12 are both divisible by 6. We get 12 divided by 6 is 2. 6 divided by 6 is 1. And now if we go ahead and multiply straight across, we get 10/7. Now we should get a warning sign here. You should see some bells and whistles going off in your head. This is an improper fraction. And as we've already talked about improper fractions and mixed numbers, let's go ahead and convert this to a mixed number. So I'm going to divide 10 by 7. 7 goes into 10 one time. 1 times 7 is 7. And if we subtract, we get 3. So this is equal to 1 and 3/7. Remember the check mark method. Okay, that takes care of that. Let's keep going. Let's look at some problems that involve whole numbers. So for example F, we have 10 divided by 1/2. So the first thing I want to do is I want to rewrite my whole number as a fraction. So I want to write this as 10/1. divided by 1 over 2. We can now go ahead and flip. So we're going to copy, dot, flip. We cannot cancel anything, so we're going to multiply straight across. We get 10 times 2 is 20 over 1. And this does simplify down to 20. All right, let's try another one involving a whole number. So same thing for this one. Again, the first thing that I want to do is I want to rewrite 6 as a fraction. This is 6 over 1. I can copy dot flip. We get 4/5 dot 1 over 6. My 4 and 6 are both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And now if we multiply straight across, we get 2 over 5 times 3 is 15. All right, let's step it up just a little bit. Let's go over to chapter 9 and let's talk about signed fractions. So remember, again, with our signed fractions, it all depends on how many are in there. So if there is an odd number of negatives, it's negative. If there's an even number of negatives, it's positive. So we're going to go ahead and work with our fractions. So what do we get? Again, the first thing I want to do is copy dot flip. We copy the first fraction, -3/4, dot, flip the second fraction. We get 8 over 5. Common factors. 4 and 8 are both divisible by 4. We get 2 and 1. And if we multiply straight across, we get 3 times 2 is 6. 1 times 5 is 5. And we keep our negative. This is an improper fraction, so we should go ahead and write as a mixed number. Again, I'm not going to worry about the negative. 5 goes into 6 one time. 1 times 5 is 5. We get a remainder of 1. So 6/5 is equal to 1 and 1/5. And we keep our negative. All right, let's try example I. We get -3/4. I'm going to rewrite 8 over 1. I'm getting a little ahead of myself. Let's go ahead and just write this as -8 over 1. We copy dot flip. We get -3/4 dot -1 over 8. Now you can write this as 1 over -8, but one thing to note is the negative can move anywhere in the fraction. It can be in the top, it can be in the front, it can be in the bottom. It doesn't matter. If we go ahead and multiply across now, we get 3 times 1 is 3. 4 times 8 is 32. And my negatives cancel. So my final answer is 3 over 32. All right, last example for this section. We have -3/5 divided by 9/10. So we're going to copy the first fraction, dot, flip the second fraction. We get 10 over 9. And then we go ahead and cancel. 5 and 10 are both divisible by 5. We get 2 and 1. 3 and 9 are both divisible by 3. We get 1 and 3. And now if we multiply straight across, we get 2 over 3. I do have one negative. I want to keep it. All right, that takes care of multiplying and dividing fractions. The next section that we're going to look at is multiplying and dividing mixed numbers. So we still need to know these basic steps because they are going to be fundamental when we get into mixed numbers. All right, let's go ahead and take a quick break, and I will see you again shortly.